thank you for reminding, right? So I have record. Okay. So anyway, now what we have done up to now, we have a Excel file. So in this Excel file, you have the Apple, the stock, the historical data of stock value of the Apple company, and we have the data from 2030, and we have the data up to 2018. So these are available. So you have to search like Apple stock market historical data. So these will be in the data in the website in the internet, where you can easily download these things, right? And this contains 1, 2, 3, 4, 5, 6 columns. So this is the date, and this is the open value. Open value means the stock value at the day starts, right? That was a patanga in stock value. So high is the highest stock value recorded in this day, and low is the lowest stock price recorded in that day. And this is the closing value. That means the stock value at the end of the day, right? So these are the number of stocks most probably, and so that's the day. So in this case, you can use either one of these open, high, low, or close stock values, right? You can use one of them, right? You can use one of them, and like we can get, for the prediction, you can use one of them. So we will use the open stock value, right? So we can use the open stock value. Okay. So in this code, what I have done, I have read the data set using the pandas.read CSV. So dot values is going like read this into a numpy array. I hope that you can remember these things. We have done this earlier, and we are interested on the open value. As I mentioned, you can use anything: open, high, low, close, anything, right? But don't think now these are not like 4 features: feature number 1, feature number 2, feature number 4, like not like that. Now we are dealing with time series data. So time series data is not like we are not going to analyze this as like sepal length, sepal width, petal length, petal width. No, not like that. Those are not the features, right? I will explain this in a bit, but we will select one row: open value, high value, or whatever. Time series data will be the data for this kind of prediction, this kind of time series data analysis, right? So this kind of a time series data should be there. And what I'm going to do, the first column is taken. That means this column is taken, so that is taken to the open value, and we are like printing it to make sure the right column is readed. So we can make sure that the right column is readed here, and using matplotlib, I have plotted, and the X label and also the Y label is given like data and open stock value. So you can see it like this, right? So this is the stock market value from stock market behavior, the stock market value or stock market price of a specific, one stock, the stock value of one stock. This is how it behaved, and this is, the historical plot from 2013 to 2018. So we have roughly around 1,200 days, 1,200 days, right? So this is the open value. Now, similarly, you can see now what we can do. I can like get the others as well, like the high value, but we are not going to use all of them. We will use only the only one, right? So high value is the column number 2, right? So this is the high value, column number 2, column number 0, column number 1, column number 2, column number 3, column number 4, right? And so let me get the low value as well, right? The low value, and let me get the final value, like the close value, right? And so it will be 4. So we can plot them in the same graph. Now what I want to show you here is that all of them are like in a similar behavior, right? Let me පොඩ්ඩක් shift වෙලා තියෙයි. හැබැයි එකම විදිහට තමයි behave වෙන්නේ. එකම විදිහට තමයි අඩු වැඩි වෙන්නේ. The fluctuations are the same, but there can be like upward shifts and downward shifts, right? So let us plot them and see. Now, in order to identify them, I will put the label like open value, and then the high value, high, low, and close. So I can change the label here as well. Now I hope you can remember these things. We have done these things. This is the label which will be shown here. Now if you are going to run it like this, you will see sorry, I didn't run this right. I have run this and then this, right? So this is what I mentioned. Now you can't see a like so you can see it's not overlapping, right? I mean it's overlapping, right? So can you see now? You can see 3-4 lines, right? Lines හතරක් පේන්නේ නැහැ, එකම line එක වගේ පේන්නේ. මොකද ඒ ඔක්කොම එක වගේ පොඩි shift එකක් තියෙනවා. Let me like plt.legend. Let me on the legend, right? So you can't see much difference here, right? So that's why like they are overlapping. Small changes when there, but they will be visible. Let us not get the whole data set, but let me get the first 100 days, right? The first 100 days. So I'm getting the first 100 days. So now you can see like, so this is what I want to highlight. So now they are like, now we are only considering the first 100 days. පළවෙනි දවස් 100 විතරයි දැන් ගන්න. Now you can see like small deviations. I mean not deviations, but shifts are there. Let me get 10 days, then you will probably see what has happened, right? So can you see now the same kind of a behavior, but like now it's obvious high value is the high value is in top and the low value is in the bottom, and the open and close values are quite the same, right? Open and close values are quite the same, right? So we have like only got 10 days, right, from here. දවස් 10ක් දැම්මම පොඩි වෙනසක් පේනවා. Now what I want to highlight is now the same behavior, right? The pattern is the same, only like the different. If you compare these things, the difference is with the what? Difference is with the like a shift, right? So it has shifted the bit. That's the only difference, right? Understood. Okay, now actually if you are not getting the like, if you get the all of the data, then probably since it's it's like we are plotting 120 days, so that the small deviations are not visible here. So everything will be like overlapped. It's like overlapped lines, right? Understood? Overlapped lines. And yes, so this is the data and this is the data behavior. Now we are actually going to select one from here, right? Only one. Like we need only the open value, right? We need only the open value. Oh, you can select anyone. Any like either open, high, low, or close, right? So let me get the open value. The legend is not needed here. And yeah. So this is what we are like interested on, right? The open value. And you can see a good pattern is there. I mean, visible patterns are there, right? Lots of patterns are there, right? දැන් ඔයාලට පේන ඇති මේක එක patterns තියෙනවා අපිට අඳුර ගන්න බැරි patterns, right? Yes, I hope that there are patterns. So roughly, like, shall we plot the first 360 days, right? First 360 days, right? Roughly. So I mean, this is the like roughly 2013 to 2014, right? මේ තියෙන්නේ මේ 2013 ඉඳන් 2014 මොකද අපි දවස් 360යි කන්සිඩර් කරන්නේ. මට මේ පෙන්වන්න ඕනේ මේකේ අවුරුදු වශයෙන් හරි මොනවා හරි විදියට මේ patterns ඇති, right? So now have a look on this and also let us plot the 362 like 720 the next year, right? So not a visible pattern but exactly, but some similar things are there, right? I mean, so you can see these patterns, right? මෙන්න මේ වගේ දේවල් වල පේනවා නේද? ඒක මේකෙත් තියෙනවා ඒ වගේ දේවල්. Yes, figure for more visibility. Yeah, we can increase the figure. Yes, you can increase the figure size and also you can increase the quality of the figure, right? Yeah, so anyway, now you can see, so this is the data set and like you can see lots of patterns are there, right? Patterns are there. So what we are going to do now, we are going to analyze this using LSTM, right? So we need to predict the stock market value using this, right? So here, now there's an important thing to be mentioned, right? An important thing to be mentioned. Now we need to, now this is the most critical thing. Yes, we have a question here. Let's see. It's better to label X as the date. Sorry. So this should be data, right? This should be date, not data. Right, okay, now what we need to do now, the most critical thing. Okay, so our task is to predict stock market values and we have a data set here, right? So we have a good data set here and we need to predict the stock value. Now, can you suggest me what are the features and labels, right? Right, so what are the features and labels? Now, can anyone guess or can anyone suggest quickly? Yes. Okay, good. So we have, let's say, answer. Features, date, label, price. Okay, so we'll see the other suggestions as well. So one says we can take the date as the feature and the label as the price. Okay, others? Yes, I need some suggestions. I need like discuss these things now. Suggestions and your like guesses. Yes, yes, others. Just I mean, just give me a suggestion. I mean, no need to be accurate, but just give a suggestion. Uh, Features, date, and volume. Okay. Label, label, price. Okay. Others? Any other suggestions? Yes. Anyone? Okay. Features, date. Right. Then label is the price, right? Yes. One might think like that. Yes. We have another one. Let's see. Label price of the stock. Yes. Yeah. Yeah. You can think it like that, but it's not really like that. You can analyze it like that as well. But the thing is now it won't recognize the patterns, right? So selecting the like feature as the date and the price. So it's I hope that it won't recognize patterns. Now thing is, so when you're like so when you are going to if you are going to select the feature as the date and the label as the uh, like the price, what's going to happen now? We are going to we are going to right. So it's like this, no? Then right. So we have some kind of right. So we have right. So we are going to design LSTM. Let's say RNN, right? So we are going to give the date, and this will give us the price, right? So what's the issue with this features and labels is that now when you are going to provide data as the feature and the price as the label, now the neural network, or to be specific, now the recurrent neural network tries to identify a relationship between the date and the price, right? So the date and price. So it's like now, I think, I hope that you are like you are saying that the data is like from 0 to 360, right? And අවුරුදු දවස් 360. ඒතර ඔයාලා හිතන්නේ මේ අවුරුද්ද ඇතුළත මේ දවස් 4යි ප්‍රයිස් එක දවස් එක තමයි. ඒ කියන්නේ අපි මේ දවස් අනුව තමයි කියන්නේ ජනවාරි 1 වෙනිදා නම් ස්ටොක් එකට මොකද වෙන්නේ? ජනවාරි 2 වෙනිදාට මොකද වෙන්නේ? අප්‍රේල් 21ට මොකද වෙන්නේ? අප්‍රේල් 28ට මොකද වෙන්නේ? දෙසැම්බර් 25ට මොකද වෙන්නේ? Right. So we are going to like identify the relationship between a specific date and price, right? So when we are going to provide the date and the price, so the RNA is going to learn the relationship between the date and the price, right? But exactly the relationship is not between the date and price, right? So that's the point here. Now if we take this, right, so one graph, let's say, right? So if you have the behavior like this, right? So what this means, right? Now let's say, right? So I want to highlight this point. Now, can you see? Now, this is only example, right? Or not a realistic thing. This is example. Now you can see, right? So, like 3 pulses are there, right? 3 or 4 pulses are there, right? 3 or 4 pulses are there. Then a huge ramp is here, right? Again, 3 or 4 pulses are there. A ramp is here. Then body pulses තුනක් කරන එකපාරම මම මේ කියන්නේ heart beat එක ගැන හිම නෙමෙයි. Right? Not like the heartbeat, but in the stock also that can be there, right? That can be there. So you can see now this is not the right. I mean this is not the right. Right. So this is not. I mean I'm not saying that. Yeah. Let me. Right. So what I want to highlight is like there's a pattern in this time series data, right? Time series data. දැන් අපි නිකන් අපි කියන වහිනකොට නිකන් අපිට පේනවා හරි මෙන්න මේ වගේ දේවල් නම් දවල්ට හොඳට අවුව තියනවා නම් පොඩි හුලඟක් එනවා නම් කළු වෙනවා නම් so we can say most probably there will be rain in the evening, right? Right, so like so we have a look on this pattern, like I mean how these things are behaving in last few days. කලින් දවස් 4-5 මොකද උනේ? එහෙනම් හෙට මේ වෙන්නේ, right? I mean, we can't say exactly like this. We can't say, okay, today is like August, what today? Uh, August 11. So we can't say August 11. So tomorrow stock price will be like this. Other August to 11 hinda stock price එක මෙහෙම වැඩි වෙයි. මෙහෙම වෙයි. අපිට එකපාර අද දවස් ගැන විතරක් කියන්න බෑ. දැන් ඔයාලා date එකයි price එකයි ගැන neural network එකක් train කරොත් that's what going to happen. Like it's going like take the date and the price. Okay, today is August 11 and for August 11 this is the price, right? No, it's not like that, right? It's not like that. Like in order to give a prediction for tomorrow, right? හෙට ගැන කියන්න what we have to do now, we have to like have an idea about the past data. I mean like the previous days or previous days, right? Consecutive previous, like let's say 5 or 6 days or 10 days. කලින් දවස් 10 මෙහෙම වෙනස් වුණා, හෙට මෙහෙම වෙයි. Right? So that's what we are going to do, right? So that's what we have to do actually. Now, I'm not saying that these kind of visible features are there, but can you see? I mean, some kind of patterns are here, right? Some kind of patterns, right? I mean, some patterns are not even visible. සමහර visible නැති patterns උත් මෙතන තියෙන්න පුළුවන්, right? Visible නැති patterns උත් තියෙන්න පුළුවන්, right? So you can see now, right? So there are lots of patterns are available. So what we need to do now, this is how we are going to analyze this kind of things, right? I mean, in order to give a prediction for tomorrow, we need to like look at the data for like consecutive 5 or consecutive 10 days. කලින් දවස් 10 ගැන බලලා හෙටත් ගැන කියන්න පුළුවන්. මොකද කලින් දවස් 10 මේ වෙනස් වෙවි එනකොට හෙට එහෙනම් මෙහෙම වෙයි. Right? But we can't exactly get a date. Okay, so today is August 11. So this is, so if it's like that, what's going to happen? Now, every year, right? So this is what happens, right? Now, if you are going like, okay, get the 360 days of the year, and okay, 360 days and the labels are the price. 360 days labels are the price. So what's going to happen? Now we are going to train it. So that means every year, August 11, the price is the same. Price should be the same. ඒවා date එකයි price එකයි නම් train කරන්නේ. එන අගෝස්තු 11 හැම year එකේම එකම value එක එනවා. Right? No, this is not. This is yes, we can use exponential smoothing here, but not necessary here, right? Not necessary. We can use the exact data set actually, right? So I will explain that. Now, what I want to highlight here is that like we have to give a prediction, okay, right? So we have to give a prediction for tomorrow, let's say. So what we need to do? We need to have a like a look about the past few days, and then okay, last few days, I mean last 10 days, this is how the stock market value behaves. Okay, then probably tomorrow, right? So it's like, I mean, independent of the date, no need to like worry about the date. If you can like have a pattern, if you can have an idea about what happens like last 10 days, now you can expect that pattern and you can analyze that pattern. I mean, RNN is going to analyze that pattern. Okay, then it's going to say tomorrow this will happen. Since like if we can show those kind of patterns, right? ඔය වගේ දවස් 10 10 කෑලි වල අපි දවස් 10 10 කෑලි වලට කඩලා අපිට ඔය වගේ patterns මේ වගේ 10 10 patterns ටිකක් මෙයාට පෙන්වන්න පුළුවන්. So if you can like segment these into 10 days, right? Portions of 10 days, and if you can train the neural network on that, okay, so it has seen like lots of I mean behaviors, lots of patterns, right? Then it can probably say what's going to happen tomorrow, right? Yes, exactly, this is time series forecasting. Yes, exactly, so this is similar to time series, exactly the same, right? Okay, so what we are going to do, right? So we are going to do this. Let's see. Now if you have a data set, now if you want to like if you want to save this in a higher resolution, you can use DPI 300. So it will be saved in higher resolution. So let me show you. So I use DPI 300. So it's like it will be saved in higher resolution. So you can use the DPI value, right? Right. So you can see it's saved in higher resolution. Right. So what we are going to do in this case, right? So we are going to, right? We are going to take this kind of segments. Not working. Yeah, anyway, fine. Right. Right. So we are going to take this kind of segments, right? This kind of segments. So what we are going to do, it's like this now. So the features and labels will be taken in this case like this. See, so the I mean, uh, yeah. So the data and the target, right? So let me take the data and target. Right, data and target. So what we are going to do, right? So it's like this. We are going to now carefully listen. Now we are going to do it like this, right? So we are going to select, like let's say 20 days, right? Understood. So we are going to select 20 days, right? So these will be data. I mean, these will be features, right? So that means the stock values of last, I mean, the stock values of 20 days, right? Stock values of 20 days, right? So this will be like the feature, right? So this will be the first feature, right? And the label will be this, right? The label will be this one. Understood, right? So that means what? I mean, features are the stock values of last 20 days, and the label is tomorrow's stock value. Likewise, it has stock value before you, right? So then what's going to happen? Huh? Then what we are going to happen? I mean, then what's going to happen? Then we are going to shift it by one, right? Then we are going to slide it. Actually, we say sliding. We are going to slide it, and what? Then this will be the feature, right? Understood. So likewise, we are going to slide it and get the features and the labels. Now I'll show you like this. Now let us take some sample values, some practice values. Right? Let me get a new code. So let me save it as 1.1 LSTMs for stock value prediction, data pre-processing. Okay, nice. So let me get some dummy values. Some random dummy values, right? So I'm going to take some dummy values, like let's say 20, yeah, 100 dummy values. Now let's take like 20 dummy values, right? 20 dummy values. And what's going to do, like it's going to, now we discuss these things. It's going to create an array with 20 elements, right? It's going to create an array with 20 elements, and the values will be in between 0 and 100. Values will be in between 0 and 100. Sorry. Right, so we have like some dummy values, right? So some dummy values. So let me create two arrays called data and target, right? Okay. So us let us assume that we are going to create windows, right? Windows of 4, right? හතරේ හතරේ windows හදනවා කියන්නේ 20 20 ඒවා නෙමෙයි අපි හිතමු හතරේ හතරේ අපි හදන්නේ කියලා. දැනට හතරේ හතරේ right. මේ වගේ එකක් ගත්තා මේ වගේ. sorry. මේ වගේ. 1 2 3 4යි මේක තමයි target එක. 1 2 3 4යි මේක තමයි sorry. 4 and this is the target likewise. Okay, so what I can do, let me like use a loop and show you this. For I in range 0 to 20, since like we have 20 values, so it will go from 0 to 20, and let me append to the data like data I to I plus 4, I to I plus 4, right, and I to I plus 4, and target dot append data I plus 4, right, and this should not go not should be going for like 20, it should go to 20 minus 4, right? So let us values. Let us print these things and see. Let us convert this to a numpy array, and then this will be like visible. Yeah. So now can you see what happens? What has happened? Let me print the values here as well, so then you can probably understand. Okay, right. So now see what has happened. Now, yeah, let me print this as like the data. And the target. Right. So what we have done here, right? So we are going to like we have a loop which is running from 0 to 60. That means 0 to 15. 0 to 15. 0 in 15 dakwa loop, right? So what we are going to do? Like we are going to append I to I plus 4. Now I is 0 initial time, so it will be like I to I plus 4. That means 0 to 4, right? 0 to 4. So that means these 4 values are taken here and it's appended here. So you can see, right? And the target, we are going to append the 4. That means 0, 1, 2, 3, 4, 68. Now you can see the target, the first value is 68. Right? So then what we are going to do, we are going to increase the I from 1. We are going to increase the I from 1. Now I will be 1. Right? So 1 to 1 plus 4 is 5. 1 to 5, that means 1 to 4. So 1 to 1, 2, 3, 4. 1 to 4. Right? So it will be appended here as the second row, and uh, to the target we are going to append I plus 4. So I is 1, I plus 4 is 5, then the fifth value 0, 1, 2, 3, 4, 5. So the fifth value will be appended here. So likewise we have created a data set, right? So finally what's going to happen now, this will be the uh, the final data, and the target will be 90 as expected here, right? Understood? Now these are the features, right? These are the features. So 4 features and label, 4 features and the label, right? Again, මේ දවසේ මේ ස්ටොක් වැලියු එක තියලා මේ දවසේ මේ ස්ටොක් වැලියු එක තිබ්බා, මේ දවසේ මේ ස්ටොක් වැලියු එක, මේ දවසේ මේ ස්ටොක් වැලියු එක තිබ්බොත් ඊළඟ දවසේ මේක තමයි ස්ටොක් වැලියු එක. කලින් දවස් 4 මේ විදිහට ස්ටොක් වැලියු එක තිබ්බොත් හෙට මේක තමයි ස්ටොක් වැලියු එක. Right? Understood? Now we know, okay, what happens from in last 4 days. According to that, we are going to predict, okay, tomorrow the stock value will be probably this value. Understood? Now we are not going to use 4, like we can use 20 or 50, we can use 20, 50 days, right? We can use, but this is how we are going to like use the features and labels. Now features are labels here. Basically now we are going to take the time, right? The time series. Now in order to predict what's going to happen tomorrow, we have to have a look on what has happened on last 20 days. Let's say last 20 days. Understood? Right? Okay. I hope you can understand this, right? Okay. Yes. So yeah. Yeah. So let me then get another code. Let me copy this. Uh, 1.2. Okay. So now we are going to like create our data set like this, data and target. We will create it like this, right? So let us get the data first, the data set. Using this, we can probably get the data set. So let us print the like okay, so these are the first 100 values, right? Right. Now we will create windows, right? Now it's like this, right? So right? So let's assume this, like, I mean, this has a 1D image. අපි 2D image අපි දන්නා 50 by 50 මේක අපි 1D image එකක් හිතමු, right? So this is the 1D image and this is the target, right? So image of a cat, right? So likewise the image and the steering angle, image, another image and the steering angle, similar kind of a thing, right? But thing is now this is not 2D, this is 1D time series, right? අර වගේම තමයි multiple values are there. Understood? Okay, so the thing is now you know, okay, so if we consider this one as an image, maybe an image 1, maybe an image 2, right? So before, you know that before applying this into the neural network, we have to normalize these, right? We have to normalize these things. right? So can you remember, when we are applying images, we are going to divide it by 255 before applying it to the neural network, right? We are going to divide it by 255. So the same thing should be done here, but the issue is that these are not images and this is not having a range between 0 and 255. So we know that images are definitely, they are having a range between 0 and 255. So what we can do, we know that the range is that, so we can divide it by 255. So then it will be probably, and it's going to definitely convert it to 0 and 1, right? But here we don't know the minimum value and we don't know the maximum value, right? I mean, we can find the minimum and the maximum value, right? And then we can divide it. But thing is, we can use we have in scikit-learn we have a specific type of functions where we can use for the scaling. Uh, yeah, so this can be, this is the code, right? So from scalar, that means scikit-learn and pre-processing sub-module, we are going to load the min-max scalar, right? The min-max scalar. And first we are going to create a min-max scale object called scalar, right? Min-max scalar object called scalar. And we can convert it to the, like, the feature range can be given here. So we are like, by default, I mean, we have lots of normalizing methods. The simplest and the commonly used thing is like normalizing it to a value between 0 and 1. That's the most common and most easiest way to do, right? But in like the coming weeks of the course, right, we are going to discuss more about these scaling and normalizing methods, right? Like batch normalization, and we have lots of things to discuss. But here, for now, we will only use the min-max scalar, where what's going to happen, no matter what's the value range, it will be converted to a value between 0 and 1, right? So we can get that object. So this is the min-max scalar object. So this object is used to convert this into 0 and 1, right? Into a range between 0 and 1. What we can do, we can have the open value and we will pass it to the this scale object, and we are going to use something called fit transform, right? So the resultant will be coming here, right? I scaled open value, so probably you can print it and check. Yes, so this should be in 2 dimension. That's the case. This should be in 2 dimension, so we can make it 2 dimension using a column vector or a, yeah, now it works. So what I have done here is I have converted to a column vector, sorry, a column vector, right? Column vector. Now we have a 1D. Now you can remember we had the 1D array, right? We have one-dimensional array. Now I have converted to a, you can use this reshape, right? So it's going to convert it to a column vector, right? That means one column and the values will be assigned to rows, right? One column and the values will be assigned to, each value will be assigned to a row. Or else you can convert it like this as well, minus +1 and -1. It will convert it to a row vector where you have one row and the values will be assigned to columns, right? But for this one, we have to use the column vector like this, right? Column vector. Most probably I think these things are there in the tutorial. I mean, the tutorial number 2 in week number 2, right? Week number 2 tutorial. I think these were there, right? The reshaping methods. And we have converted. Now, the purpose of converting this is now. Otherwise, the scaling won't work since the scaling, the fit transform method is looking for a two-dimensional array. අර fit transform method එක බලාගෙන two dimensional array එකක් කරනවා. ඒ හින්දා අපිට like we can't give a one dimensional array. We have to convert it to two dimensional and give, right? So what has happened now? You can see these set of values. Let me print the first 10, then probably we can. We open value එකේ පළවෙනි 10යි මේකෙත් පළවෙනි 10යි බලමු. Right? So what you can see, now they have been converted into a value between 0 and 1, right? Value between 0 and 1. So min max scaling, right? So what's going to do, like, can you imagine how this happens? මේ min max scaling එක කොහොමද වෙන්නේ කියලා කාට හරි හිතන්න පුළුවන්ද? Yes, can someone imagine what's going to happen? Yes, anyone? Min max scaling, how it's done? As I can remember, yes, we will configure that. Now the min max scaling is done like this. Okay, when x value, now let's say if you want to convert a value called x, right? So x min value, max value minus min value. Probably this is the right. Okay, so let's assume that a specific data set, let's say, right? So the min value is, let's say, 40, and max value is 80, let's say, for example, right? Okay, so now what happens? Okay, let's say 40, x is 40. After the x can 40 කියලා. එහෙනම් min value එක වෙන්නේ like 40 minus 40. හරි. අපි තුමුක x 40යි කියලා. අපිට convert කරන්න තියෙන value එක තමයි 40. එහෙනම් මේ equation එකට දැම්මහම මොකද වෙන්නේ? 40 අඩු කිරීම 40, max value එක 40, min value එක 40. එතකොට බිඳුව බෙදීම whatever the thing is 0, right? අපි හිතමුකෝ x value එක 80යි කියලා. මම හිතන උඩ ලියපු එක මම ලියපු වැරදි වගේ. Let's say x is 80. So it should be like 1, right? X is 80. That's correct, right? Let's see. 80 minus 40 divided by 80 minus 40. So it's 1, right? අපි හිතමුකෝ x කියන්නේ 60යි කියලා මැද වැලියු එක අපි ගමුකෝ. නේද? 60යි 40යි මැද තියෙන්නේ 60 40 80 මැද තියෙන්නේ 60නේ. එහෙනම් අපි කියමු x කියන්නේ 60යි කියලා. Let's say x is 60. So then it's like 60 minus 40 divided by like 80 minus 40. So it's like 20 divided by 40 is 0.5, right? So this is the equation that you are going to use, right? Min max scaling එකේ වැඩ කරන්නේ මේ equation එක. මොකක් හරි value එකක් තියෙනවා නම් ඒ value එක 0.1ටයි convert කරන්නේ මේකෙන්. Whatever the value, this is the x is the value that we want to convert into between x and y. And you need like get the value of the minimum value of the data set and the maximum value of the data set and the minimum value of the data set. So if you are going to apply this equation, any value of the data set will be converted to 1 and sorry between 0 and 1, right? Then min max scaling වලට apply කරන්නේ මේ equation එක. Yes, we have a question. Dividing by the range between min and max. Yes. Yeah, the range. Yes. I mean, මේකට වඩා අපිට ලේසියක් අපි apply කරලා බලමු. Okay, so let's take an image, right? Example image. So in image, you know, the min value is 0 and the max value is 255. So what our equation? X minus 0, then maximum is 255 minus 0. So මේක නම් obvious නේද? මොකද එන්නේ? Pixel value එක 255 වුණොත් මොකද වෙන්නේ? 255 ඍණ බිඳුව ප්‍රදීම 255 ඍණ බිඳුව 1යි. x බිඳුව වුණත් එහෙම මොකද වෙන්නේ? බිඳුව ඍණ බිඳුව ප්‍රදීම 255 ඍණ බිඳුව බිඳුව, right? Understood. So this is the equation that we are going to like use in like if you want to convert anything into between 0 and 1. So this is called the min max scale, right? Then අපිට make a manual. So what we can do, like we can find the maximum value of the open value and the minimum value of the open value, and we can apply this equation and get the same thing. තේරෙනවද? මේක අපිටත් මේ වැඩේම කරන්න තිබ්බා. මේක apply කරලා අපිටත් මේ වැඩේම මේ equation එක දාලාම කරන්න පුළුවන්, but like we can use the library. And what's the specialty about this live? I mean, this method that we are going to use, the scaling method. What's the specialty about this is that if you have multiple columns, again, columns then make up a column again. But if you have multiple columns, I mean, like let's say now we are going to apply the all 4 rows, all 4 columns, right? And make them apply still it can, I mean, convert it to 0 and 1. What's going to do? It will do it in individual by, I mean, column by column. It will convert this to 0 and 1 separately, this to 0 and 1 separately, and this separate, right? So column wise individual conversion can be done if you are going to use this method. When min max scaling use column wise individually, independently, you can convert it to 0 and 1, right? So that's the advantage. Yeah, so it takes the column max and column min. Yes, exactly. It's I mean, inside the method, it's going to take them and do whatever the necessary thing. So we need to no need to like use a manual method to do this, right? So scaling down, right? And yes, so then what we have to do, whatever the thing we implemented last time, right? So now no, so not this. Right, now we have to multiply this, I mean, sorry, modify this. Now this should go for like data, sorry, yeah, open value dot shape 0. Now I think now you should be familiar with these things, right? But open value dot shape, or the open value dot shape again, right? So it's going to give us the, I mean, the right. Sorry, what happened here? Sorry about that. Right. So now let us create a window size, right? That means the width of the feature. අර feature එක size එක අපි 50 කියලා දාම දවස් 50ක් තමයි. ඒ කියන්නේ අපි හෙට එක predict කරන්නම් කලින් දවස් 50ක් දිහා අපි බලනවා. Previous 50 days, right? So then we can replace these things like 20 minus window size, this plus 20, this plus 20, right? Understood, right? Uh, so now the data set is created, right? So can someone tell me like how many like data and target? Okay, data is a whether it's like a two-dimensional array or one-dimensional array. First, data කියන එක two-dimensional array එකක්ද one-dimensional array එකක්ද කියලා කියන්නවට. Yes, the data is two-dimensional array or a one-dimensional array. Two. Okay, good. Now can you again tell me how many rows and how many columns? Okay, so then the next question, how many rows and how many columns? One rows and 50 columns. No. One rows and 50 columns. No. Others? $50 and 4 columns. No. Anyone? One row, data count 50 columns. No. Not. Others? Can anyone? I mean, if you just look at the for loop, you can tell the dimensions. You can identify the dimensions. Just look at the for loop, then you will probably. Yes. 30 rows and 1 column. No. No. Just look at the for loop. I mean, how many times the for loop will run? Right? So that will be the number of rows. Right? Data.append. අපි append කරන row එකක් නේ. These things you should know, right? We have done this. I mean, can you remember that we appended the image in when we are training the cat and dogs thing, right? So how many images, how many rows were there? Like 24,946. Can you remember the exact number? So that number of rows there, that means that number of times this for loop runs, right? For loop එක run වෙන හැම පාරටම row එකක් තමයි හැම වෙලේම append වෙන්නේ. That's the obvious thing. We have discussed these things, right? Sorry, another mistake. I have done a mistake. Okay, what is this? No, not this. Sorry about this. Yeah. So now it's my bad. Sorry. Yeah. Sorry about that. Now I will modify and probably you can answer it now. Sorry, it's my bad. So I will modify it and then probably you can ask the answer. And also I will print open value.shape as well. Okay, so now can someone tell me? Now, sorry about that earlier case. Now you should tell the answer. What's the shape of data? Two columns, sorry, two-dimensional. Data is a two-dimensional array. So how many rows and how many columns? 109 rows, 50 columns. Yes, good. Right, 129 rows, 50 columns. Why? I mean, you can see now we are appending what? 0, I plus window size. That means window size is 50. So a 50 size window is appended. That means 50 columns are there, and the number of times the loop runs, that decides the how many appends take place, right? How many appends take place. Append කීයක් වෙනවද කියන එක තීරණය කරන්නේ loop එක. මොකද එක loop එකකට පාරක් නේ append වෙන්නේ. ඉතින් loop එක run වෙනවා open value dot shape minus window size. That means open value is this and the window size is 50, so it will be basically 129. Okay. Is it okay now, Jeffrey? Is it from mine? Is it? Is it from mine? I mean, mine or some other one? Okay, then it's fine. Okay. Now can you hear the same? Okay, better, right? So sorry about that. I mean, the issue is actually now I have my setup with mics and screens and other stuff. Everything is there, but they're at home. Now I want to travel Colombo. I mean, like I have traveled to Colombo and Copenhagen these days due to some reason. So that's why now I mean some issues are there. Now the quality is not there when I'm doing this outside, but at home I have everything set up. But anyway, now next week onwards probably I will use the same format, the same quality will be used from next week onwards. So if there is any like inconvenience caused, please yeah, okay, right. So then I think so we have like completed the data set, and this is okay and this is fine. So let us print the shape to make sure. Yeah, sorry. Now we have now these are Python arrays, Python lists. So what we have to do? Have we imported NumPy here? All right. So first import NumPy, and we have to now convert them as now let me do it in the last cell. Or else I can do it here. Yeah. So then we can convert it to numpy arrays. Data equals np.array data. My target equal np.array target. Okay. So now probably we can print it and see the shape. Yeah, right. So 129, 50. Now one is like it's saying one value is there per column, right? One value there is for one column. That's what it says. Right. Okay. So I hope that it does everything we want. And now what we can do, we can convert, we can save them using np.save data. Like we can give the name, you can give the name, data, and the target. So now you can see the data and target are saved here, right? The data and target are saved here. Uh, um, okay. Yes. So what I was doing is now these were, I think these are saved here. Uh, yes. So it's saved just now. Yes. So data and target are saved here, right? So we have the data and target, and it contains like 1209. So let us get the next code, right? We can get a new notebook. So let me LSTMs for stock value prediction, model training. So then what we can get, what we have to, include is the files we just saved. They will be loaded, np.load, using np.load. So these are the things we have already did, right? So these are the things that we have already did. So that's why I'm not like repeating those stuffs. So we can give the name data.npy and the target np.load, like the target.npy, right? So those two can be loaded, right? And what we can do, we can now like I want to split the train and test data, right? But I'm not going to use the train test split here, right? I'm not going to use the train test split here. I can use, but I'm not going to use. It's totally fine. You can use the train test split. But what's going to happen if you are going to use the train and train test split? We can't visualize it. We can't visualize the graph. Now, you know that, let's say, let me show you, let me get the uh, import numpy, sorry, import, yeah, the matplotlib thing, and plot it. Yeah, so this should be 2.0. Okay, so let me put the target. Okay, so let me plot the data. Now you have like, now can I plot data? What about data? Can I plot? Can I plot data? Can I plot data? I mean, this is what a two-dimensional array, 1209 rows and 5 columns. Sorry, 50 columns are there, so we can't plot it. But you can plot one row. But row එකක් plot කරන්න පුළුවන්. Right, you can plot one row. මොකද ඒකේ තියෙන days 50යි. Right, so 50 days are there. Right, 50 days. Right, so this is, I hope that this is the first 50 days, is it? පළවෙනි දවස් 50 නේද මේ තියෙන්නේ? Yes, the first 50 days. Now you can see like this kind of area, right? The first 50 days, right? We can plot this second 50 days. So this is the second row, right? So second 50 days. So we can't like, now can someone, so I mean, it's not going to work. It's giving an error, right? So you can't plot it. But can we plot the target, right? Can we plot the target? Target එක plot කරන්න පුළුවන්ද අපිට? පොඩ්ඩක් හිතලා බලන්න. මට මේක ඔයාගේ ඔළුවේ, I want like visualize this in your mind, right? So how these two-dimensional thing is there, rows and columns, and how the target is there. Yes, so can we plot the target here? අපිට target එක මෙතන plot කරන්න පුළුවන්ද? Right, so what target contains, right? What target contains? What the target එකේ තියෙන්නේ? Now target contains something like this. I mean, you can see the target is like this: 68, 53, 95, 44. Likewise, it's going to go up to here. I mean, it's like from here to here, right? I mean, so it's the same like the data set. Like, I mean, it's same like the open value, right? Yeah, you open target එක open value වගේම තමයි. Value 50ක්, and මේක නම් 4යි. හැබැයි අපේ එකේ values 50ක් නෑ. මුල value 50 නෑ. Right? Understood? So you can put the target, right? Right? So target is what? I mean, like 1200 whatever thing minus 50. Now continuous data is there in the target, right? So what's going to happen? Like if I'm going to use the train test split, our train test split එක use කරොත් මොකද වෙන්නේ? I will lose, right? This, I mean, this nice continuous data will be lost. I mean, it's fine for the neural network. Neural network can train. Now it's like this. Now you have like 1,200, sorry, 1,200, roughly 1,200 rows, and each row contains 50 days, right? So when you are going to use train test split, what's going to happen? So these, what? These, I mean, to train and test data, these data set will be shuffled and assigned values, right? So then the target will be also shuffled, and some of the targets will be there in the train target, and some of the targets will be there in the test target. So what's going to happen? This nice little continuous thing will be lost, right? Clear now? So what we are going to do, right? What we are going to do, I mean, at the end, I will show you, right? So at the end, I'm expecting this kind of a, let me show that. This one is this one. Yeah, I'm going to do the prediction, and I'm going to plot this kind of I mean the tested, I mean predicted and actual results, right? Predicted and actual results, I'm going to plot them. So then probably you can see a continuous stock values, right? If I'm going to use the what you call this train test split. මොකද train test split එකේ මේවා කළොත් එහෙම මේ train target test target කියන්නේ මේ target ටික මාරු වෙලානේ එකට වැටෙන්නේ. එතකොට අපිට ඇඳ ගන්න බෑ. නැත්තම් neural network එකේ ප්‍රශ්නයක් නැහැ. neural network එකේ මොන දවසද ආවේ කියන එක ප්‍රශ්නයක් නැහැ. මොන දවස් 50ද කියන එක ප්‍රශ්නයක් නැහැ. It's not going to be a matter, but the continuous data will be lost if we use the train target. So train test split, since it's like randomly assigning train target, test data, train target, right? So what we are going to do in this case, we can manually get the train data. I mean, this is not necessary. You can use the train test split, but you can visualize it like nicely like this. So train data, I'm going to use the first 1000 and test data, the remaining 209, the remaining 209, 1000 to end. So similarly, target will be the same. Right? Okay. So after this, let me plot it and show you the targets. Right? You will see an issue here. In target, and the test target. So I'm going to plot the same, right? I mean, plot everything in the same graph. Then plt.legend, I'm going to on the legend, and also let me put the X label, data, and plt.y label, target. Now, what's the issue here? Can someone like explain what has happened here? Yes, can someone explain what has happened here? Yes. දැන් සාමාන්‍යයෙන් අපි මෙතන වෙන්නේ ප්‍රශ්නේ මේකයි, right? In plt.plot, right? In plt.plot, we have to usually provide set of x values and set of y values, right? Set of x values and set of y values. But this also works with, I mean, it works with this as well. Only y values can be taken, right? Right. So what's going to happen now? If you have, if you're going to provide y only. So let's assume y is like this, like set of y values. So if you are going to pass it here, so what it's going to do actually, this will be like it will be assigning set of x values and plot this. So it will assign set of default x values, right? And these x values will be like 0, 1, 2, 3 up to whatever the value. Then අපිට මේක අදිද්දී සාමාන්‍ය usual this is the normal syntax. That means we have to provide both x and y, right? Both x and y. We have to provide both x and y. But still we can plot it using only the set of y values. අර y values use කරලා විතරක් අඳින්නත් පුළුවන්. ඒතකොට මොකද වෙන්නේ? අපි තුමු y value 100ක් තියෙනවා කියලා. අපි plot y කියලා විතරක් දෙන්න බෑ. අපිත් එහෙමනේ. plot y value ටික විතරයි දීලා තියෙන්නේ. So what's going to happen? It's going to like give us the only the so it will assign default x values, default set of x values. So those values will be like, if you have like 100 values in y, it will create x as default like 0 to 99. Yeah, x එක default හදනවා 0 to 99. Understood. Now here what happens? Now the test targets, like these are the test targets are what? They are, what we need to plot is 1000 to 100. These should be plotted with 1000 to 100. And now this should be plotted like x value should be what? X value should be from like 1000 to 1209. Right? මේක x value එක වෙන්න ඕනේ 1000 ඉඳලා 1209 දක්වා. ඒතකොට තමයි මෙතනින් ගානට ඉතුරු ටික එන්නේ. Right? But here what's the issue? Now එහෙම වුණොත් තමයි මෙතනින් ගානට ඉතුරු ටික දෙන්නේ. මොකද දැන් මෙයා ඇඳලා තියෙන්නේ බිඳුවේ ඉඳන් 209ක් ඇඳලා තියෙනවා. Right? හරිනම් මෙයා ඇඳෙන්න ඕනේ මෙතන. Right? So it should be like from 1000 to like this should be like 1209 this point, right? But since we haven't give a x range, it's going to get the default x. So this is 0, right? And this is like 209, right? So that was what has happened here. So what we can do, the first one is fine. It's like going from 0 to 100, no? 0 to 1000. So what we can do here is we can manually add the x range. So you can do it np.arrange 1000 to 1001 to 210. No, sorry. Yes, this one. Now the x range is like 1001 to 2009, 1001 to 1209, right? So now we have what we expected. Understood? So this is the graph. We have splitted the data in like first 1000 days, right? So the first 1000 data will be used to train the neural network, and we can use the remaining 209 set of data to test the neural network or evaluate the neural network, basically test the neural network, let's say, right? Okay, so what we can do now, we have to train the neural network. We can train the neural network now. So right, so I can you have to use LSTMs as we already discussed, so you know what happens with the LSTMs. And other than that, the other important thing is, now here we are passing like windows of 50, right? Windows of 50, size of 50. So the neural network also should be designed to a similar architecture, right? It should be designed to a similar architecture which can accept like 50 days or 50 time series data, right? So what we can do, let us, I mean, get the neural network architecture, the LSTM type neural network architecture, and add some layers, right? Add some layers, low layers in the sense, now we have to add few LSTM layers. So you know, as we discussed in last time, like we need to have LSTMs. We are not going to add them like convolutional layers or feed forward layers, right? But we are not, I mean, LSTM layers, we have like 3 or 4 maximum layers. Other than that, we are not going to use that amount of LSTM layers in a neural network. A few LSTM layers will be used, since like they have lots of memory, right? LSTM contain lots of memory, as we can, as you can remember on last week, as I mentioned, like forget gate and the the cell update and the cell state, right? So likewise, we have lots of available uh, memory is there, so already. So like few layers would be enough, right? So let me get the previous code and see how we can implement this after plotting it. Yes, so this is the neural network architecture we are going to use. And let me, yes, so let me close other unnecessary, yeah. Okay, so we are going to use like the dropout layers as usual, and some set of LSTMs, I mean LSTM layers, and as well as some dense layers, right? Dense layers are also there. Uh, so yeah, so let me get the code for this one, right? And add the few LSTM layers, and then probably we can train it. So model is equal to sequential as usual. Now sequential layers, what? I mean not layers, sequential model is an empty neural network will be created. And what's the specialty about this? I mean the sequential type models, that they are like will be created empty by default, and we can add layer by layer, right? So that's the specialty. And the last layer will be like the layer that we are going to add at the end, or as the last layer will be the output layer of the neural network, right? So let me add the LSTM layer, model.add LSTM. So we have taken that here, LSTM, and then we have to mention few parameters. We have to include few parameters. How many cells are there, right? So it's like neurons now. Feed forward neural network and others, we are referring them as, now you can remember these things. Now in CNN, sorry, in feed forward neural network, we refer them as what? Uh, I mean, neurons, right? And convolutional neural networks, we are referring them as kernels, right? The same thing, the same idea. But in LSTMs and other RNN type models, RNN type cells, we are calling them as cells, right? මේකදී අපි කියන්නේ cell එකක් දැන්. dense layers නැත්නම් අපි feed forward neural networks වලදී කියන්නේ neurons කියලා. convolution neural networks වලදී අපි කිව්වේ kernels කියලා. But the same idea, then here we are calling them as cells. So cells given should be given like this. Units 96. That means I mean a random value. No need to have like 96. You can use your own value, but here I'm using a 96 like a cell, right? Cell of 96. So then what's going to happen? So we have to view the input shape, and it's obvious what's the input shape. Can someone, while I'm typing, can someone tell me what's the input shape? Yes. Yes. What the input shape again? Yes. Don't say like data.shape one. Numbers, can you tell me the data shape? Someone? Neural network input කරන්නේ මොන වගේ එකක්ද? Yes. Neural network එකට input එන්නේ මොන වගේද? කියන්නේ. Good. One answer is there. 1050. No. Neural network neural network එකපාරකට දාන size එක මොකද්ද? එකපාරකට දාන size එක මොකද්ද? 50. Yes, good. 50,1 එකපාර දැන් අපි හිතන්න images 1000ක් තියෙනවා. Images 50 by 50 image. So the neural network is taking 50 by 50 image. So that's the input shape. Here we are like having 50,1. I mean 50 days at once. So the size will be 50,1, right? Size will be 50,1. So that's what we are going to get it from. I mean get from here. And the other thing that like this is now. This is like this. We are going to give 50 inputs, but thing is that we have, right? So we have 1, 2, 3, 4, 5, 6. Let's assume these as cells. Now this is the cell number. Let's say right? cell number 0, cell number 1, cell number 2, cell number 3, cell number 4, dot, cell number 50. Cell number 50, dot, 95. Sorry. Right, and here the other thing is that okay, now we are going to like provide 50, right? අපේ input එක 50. එතකොට අපි හිතමු මෙහෙමයි කියලා. So the input will be provided like this, right? So there will be no inputs to the cells after this. දැන් අපි ගාව 50 නේ තියෙන්නේ. අපි 50 දෙන්න බිඳුව 1 2 3 4 50 right ඔය 50 තමයි අපි දෙන්නේ හැබැයි මේවට inputs එන්නේ නැහැ so what's coming you know this right I mean this has a memory flow this side right right so there are like some cells which like don't get input right but still fine since the memory will be flowed right to the remaining cells අනිත් cells තිබ්බට වැඩක් නැත්තේ නෑ මොකද අපි මෙහි 50 මේ පළවෙනි 50ට දුන්නාට ඊටු ටිකට memory එක යනවා මේ පැත්තෙන් right no need to have inputs right so that's the idea and the other thing is like let me add another cell right so let me add another I mean yeah the units another 96 and what I want to highlight here this will we are going to add another layer here අපි තව layer එකක් add කරන තව LSTM layer එකක් ඒතර 96ක් අපි හිතමු වෙන color එකක් ගමු we can use another color right so we are going to add 96 I mean no need to have 96 but we are going to add 96 so then what we have to do we have to give a parameter here called return sequences right return sequences true return sequences true so then what will happen if you are going to make return sequences true what's going to happen like it's like this right? It's like this that means there will be I mean all the cells of that layer that means this layer right all the cells of this layer are giving outputs right now you may wonder okay so what's going to happen I mean is that means like if you are including a layer with 96 the remaining layer also should be 96 no not like that right එහෙම වෙන්නම ඕනේ නෑ right so let me like add the other layer and I will show you then so let me add the dropout layer also I will make return sequences true from this as well right return sequences true in this as well and let me add the dropout layer right and dropout layer from with the probability of 0.2 you can use your own number and see what are the results right and like let me add another LSTM like let's say okay I mean this is only example right okay 92 let's say 92 right and return sequences true now if you are going to have 90 6 here, what's going to happen? Yeah, so what's going to happen? 92. So then මෙතන යට එකේ 96 තියෙනවා. Yeah, return sequence is true. But I mean, in the second, I mean, the third layer, we have only 92. So what's going to happen now? Huh? What's going to happen now? Yes. So then it will be something like this. Right? So 4 layers, I mean, yeah, 4 layers will be like shifted and the 96 will be kept like this. Yeah, මේ හතර අයින් කරනවා මෙන්න මේ පැත්තට දාගන්න. ඒතර අර හතරෙන් යන්නේ නැහැ. Right? So these will be like there will be another, I mean 92 will be there, but the first 4, like they will not be, I mean they will not be connected to the, I mean any cell in the upper layer. මොකද මේකේ 92යි යට එකේ 96යි, right? The, I mean the second layer has 96, but the third layer has 92, right? So the first 4 won't be connected to any cell. So then the 92 will be shifted and aligned to the right side 92 cells of the second layer. Second layer එකේ තියෙන අනිත් 92ට ගිහිල්ලා align වෙනවා. Right? So that's what happens. Right? So then we can have another, probably another, I mean you can select these cells, I mean the width of these cells. I'm just adding cells. But somehow finally what we have to do now, this is what classification or a regression or what kind of a problem? Yes, a easy question. Is this a classification problem or a regression problem? Yes, exactly. This is a regression problem. Now, okay, so now I'm planning to add the last layer here. So can someone tell me what should be the last layer? How many cells should be there? How many cells should be there? How many cells should be there? Yes, good. One. Sorry, one. So there should be one layer. I mean, one neuron at the last layer, right? So in this case, what's going to happen? Now, it will be something like this, and only one return from the previous, I mean the next layer, right? කලින් layer එක එක return එකයි දෙන්නේ. So in that case, what you have to do, right? In that case, what you have to do, if you are going to like have this before the last layer, you have to make the return sequences false. So then there won't be like outputs coming from all the cells. Output from only the last cell will be given, right? The output will be given from the last cell, not all the cells. So it will be connected to the, I mean the last cell, right? So if you are in one layer, I mean one cell at the end. So what you can do, module.add a dense type neuron, right? So you can have a dense type neuron, right, with the activation. Can someone guess the activation? The last neuron. Yes, Sorry, can someone guess the activation quickly? Others? If you remember the basics. Okay, others? So we have two answers here. Others, can someone guess? This is a regression type problem. And with that, can someone guess? Yes, others? What about others? Yes, anyone, please? Yes, what about others? Sigmoid? No, no, no. Sigmoid? Now, I mentioned these things, right, specifically. Now, for regression problems, you are going to use linear activation, right? Or else you can use ReLU, right? Here you can use ReLU since like it's not containing minus values, right? So you can use ReLU or else you can use linear. Now you can't use sigmoid. Why? Right? Sigmoid is going to like give output like this. I mean, now I hope you can remember these things, right? I mean, it's giving output like this, right? It's not linear now. This, I mean, we are expecting a linear, right? So these are for classification problems, right? Sigmoid and softmax, these are for classification type problems, not for regression, right? So you have to either, I have specifically mentioned these things, right? So please have a look on the previous weeks. So either linear or you can use ReLU. So I mean, if you are going to use ReLU, make sure that the output is not having, I mean, you are not expecting minus values. So you can't do it for the self-driving car. Why? Self-driving car, you can get negative values. The negative angles can be obtained, right? But here, no negative values can, I mean, not no negative values are there, the stock value. So then you can use ReLU, but or else you can use this one. I mean the linear. So then we have to compile the model, compile it. Okay, can someone give me the loss? Yes, the loss. What's the loss? You can answer this one. Yes, good. So it's MSE, mean squared error, and the optimizer then, optimizer, right? So optimizer will be, we can use the Adam optimizer, right? Yeah, sorry for that. And you can use the Adam optimizer, and others are the same. Like as usual, we can use the Adam here, and so that's pretty much everything, right? So then we can probably run this, and there's the issue in the first one. Return sequences true. Right. So then we can train the model dot input 0 is incompatible layer LSM to an expected end in 3, found end in 2. So what's the data dot shape? Okay, so why it's incompatible? It says expected ending 3, found ending 2. Sorry. Ah, 1, 2. Not up to 1, 1, 2. Then probably then only 1, 2. That means then you are going to get 50 and 1, right? I have even like 1. That means it only take this one. Typing mistake. Then probably it should work. And model dot fit. Model dot fit. Train data. Train target. And validation. Let's do the validation as well. Validation. Let's give the epochs first. Like let's say 100 epochs, and then we can give the validation split, right? Validation split like 0.1, let's say. So it's training now. It started training. I don't know. Validation loss is decreasing, right? Yeah, so this will take time, right? So anyway, what you can do up to then, import We can put the label like loss, and also we can put the validation loss as well. Validation loss. So can you get the accuracy here? Yes, can we get the accuracy? Right, so can we get accuracy? My question. Yes. Can we get accuracy? Yes. For a regression problem, can we get accuracy? Yes. No. Okay. Others, one says no. No. Yes, exactly. We can't measure accuracy for regression programs. Why? I mean, while this training completes, uh, I can explain you that. Okay. So let's say now in a uh, in a classification problem, let's say. So let's say the actual and the predicted targets are these. So these are the actual targets and these are the predicted targets. Okay, so what's the accuracy here? What's the accuracy here? How many predictions are there? How many predictions are there? 5. How many correct predictions are there? 1, 2, 3, 4. Right? So the accuracy will be what? Accuracy will be, yes, 0.8, right? Understood. Now these are like 5 predictions given, and like out of those 5, 4 are correct. 4 are correct. So we can say from 5, 4 are corrected. So we can say the accuracy is this. Right? Okay. So in a regression problem, what happens? Right? Regression problem, what happens? Like let's say, okay, now it can contain, okay, so these are the actual values, right? So let's say the stock market value. I mean, so the values we have converted to 1 by 0, 0 and 1. So 0.56, 0.78, 0.91, right? 0.2, 0.5, and here 0.54, 0.77, 0.8, 0.21, 0.44, right? Now what's the accuracy here? You can't measure accuracy, right? So I mean, if you measure the accuracy, what's the value here? I mean, the accuracy might not give the value again. Yes. If you are going to measure the accuracy in this case, what will be the accuracy? Yes, zero. Good, right? So it's zero. I mean, now five predictions are there. The prediction, I mean, it's not correct, right? But I mean, we can see that, like here, these are very close, almost the same. These are almost the same, right? Can you see? Right? But here these are, I mean, bit different, but right, almost the same, right? With like few decimal places. I mean, few decimal like values, right? The difference is only between like few values, right? Understood. But the thing is now, if you measure the accuracy, uh, you can't measure something called accuracy in regression problems, right? But what we can do in regression problems, we have another measurement, right? Similar to accuracy, we have something called, right? So this is quite similar to the accuracy, but it's called R2 score, right? The R2 score. So what do you mean by R2 score is like this. Right, so let's say 5 predictions are there, right? And for this case, let's say, I mean the stock value and the like the date, let's say, and let me mark, right? So blue ones are the actual targets, right? And the red ones are the predicted targets. Right? So red ones are the predicted targets, right? And the yes, yeah. So then you are going to mark something. So let me call like these are right like y actual, and these are like y predicted, right? So it's like this. Now this is y1, this is y2, this is y3, and this is y4, right? And we call this as, we can call this as ya1, this as ya2, this as ya3, sorry, right? ya3, this as ya4, and we can refer this as y predicted, yp1, yp2, yp3, and yp4. Understood. Now we are going to like get called something called y bar. Is it y bar? Let me have a look on this one. Probably. Uh, yes, so it's like this. Now we can define a term called y hat, right? Y hat, and it will be y hat will be sigma I equals I equals sorry I equals sigma I equals uh, 1 to n, right? I equals 1 to n y a I actual y's divided by a. Now what is this? We can refer it as mean of y a. මේ YA actual කට්ටියන්ගේ mean එක, right? So we can like mark it somewhere here, let's say. මේ y actual ඔක්කොම එකතු කරලා n වලින් බෙදනවා. n කියන්නේ 4යි මෙතන. 4ෙන් බෙදනවා. Right? So then what we are going to do, we are going to measure these, we are going to measure these values, right? This one. This one and this one. And this one and this one, right? And this one and also this one, this one and this one, right? So we say the y score, the R2 score is, right? R2 score is equals to 1 minus sigma, right? I equals n to 1 to n, right? Y yeah, so y actual I minus y predicted I, right? Divide by, let me shift this to a bit further, okay? Divide by I equals 1 to n y bar minus y predicted I, right? So this is what the R2 score is about, right? The R2 score, right? So it's basically Yeah, so since this is getting the square root, I mean the sides can be changed. Make a method and pull make a method and pull make a method. Question since we are getting the square, so that's what called R2 square, right? So this is what you call, right? And I mean, like, can you see now YA minus YPI? That means this length, right? Here, can you see this length? Right? And y dash, sorry, y bar minus ypi, that means this distance, this one, right? So likewise, we are going to like, so here for the, I mean, the upper term, we are going to get the sigma, that means summation. We are going to get the summation of, right, this one, this one, this one, sorry, I will cross them, this, sorry, yeah, here, now, this distance and this distance and this one and this one, right? So those are the terms coming to the, I mean, the uh, numerator, and denominator, let me use a round, and the denominator terms are the mean minus the predicted. So mean is this line, so this line is y bar is this line. So we are going to take this, sorry, I'm going to like mark it with a circle. Sorry, not a circle. Let's take a minus mark, this one and this one, right? So the predicted one minus the mean, and here the predicted one minus the mean, and here also predicted one minus the mean. So it's divided by this one, right? So those distances should be added, and like we have to get the error and divided by 1. Now, R2 score is similar to accuracy for regression problems. Now, for classification problems, we have accuracy. For regression problems, we have R2. That means when, I mean, like you can see now, in order to R2 score to become 1, right? In order to R2 score to become 1, like what term, the numerator should be 0 or the denominator should be 0? Yes, numerator or denominator. I mean, if let's say like R2 is to become 1, R2 එකට R2 score එක එක වෙන්නේ කොහොමද? මේක තියෙන එක අඩු කිරීම මේ term එක. Right? So if what happens now, if the yeah, if the numerator becomes 0, R2 score becomes 1. That means what? Numerator එක එක බිඳුව වෙන්නේ කොහොමද වෙලාවටද? මේ distance ඔක්කොම, right? මෙන්න මේ cross එකෙන් mark කරලා තියෙන distance predicted එක, like the distance marks with cross, that means the distance between the actual and the predicted, right, of each individual target. If that becomes 0, right, if that becomes 0, what's going to happen? The numerator will become 0. ඒක බිඳුව වෙනවා කියන්නේ මොකක්ද? That means what? The actual is equal to the predicted. So if the actual is equal to the predicted, the error becomes 0 and the numerator becomes 0. That means R2 becomes 1. So similar to the accuracy. But like what happens when the distance between each predicted and actual becomes higher and higher, R2 is becoming what? R2 is becoming, right, less and less, and it's going far from 1. තේරෙනවද? මේ error එක වැඩි වෙන්න මේ distances වැඩි වෙන්න R2 එක එකෙන් ඈත් වෙලා යනවා. මොකද එකෙන් ලොකු ප්‍රමාණයක් අඩු වෙනවා. මොකද like if this error term, right, so if this error term, right, this terms increases, R2, what's going to happen? R2 decreases, right? It's like going to 0. That's what's going to happen, right? So this is how we are going to measure the accuracy of regression problems. Not the accuracy of the regression problems, sorry. The performance of the regression problems. this accuracy of regression problems we can say, but not correct. Like we have the measurement how quality the regression this neural network is. We can measure the R2 score, then it's going to give us a measure about the like the performances, right? Yeah, fortunately, like we have a trained neural network now, right? What's there? Model.history.history. Sorry. It should be plot, not even show. Sorry about that. It should be plot. Yeah, slight little deviations are there, but seems to be good, right? Seems to be good, but I think we can fine tune this and like smooth the validation loss. The training loss is quite good, but the validation loss is fluctuating, right? So probably let's see the early code. Yeah, the fluctuation is there, but anyway, right? So we can smooth that. So you can try it and like change the architecture and try to change the activation functions and try to like smooth the validation loss. Otherwise, this is a quite good one. I mean, overfitting is not there, right? I mean, you can see a fluctuation, but eventually it decreases, right? At the end, I mean, continuously it's decreasing, which fluctuations is decreasing, but it's not increasing. The validation loss is not increasing, right? So it means like it's not like this, right? So it's not like this. I mean, this is the case. This is called the overfitting, but this is, I mean, fluctuating, but I mean, if we can smooth this, it's something like this, right? So if we can smooth these ramps, if you can smooth these impulses, then it's a smooth curve, right? So this is a good model, as we can see. So then what we can do, like yes, so we can now measure the R2 score probably. So there is a function from sklearn, we can get it. Sklearn.metrics probably, as I can remember, metrics import R2 score. So we are going to measure the R2 between, we are going to apply the R2 score function, and we have to apply the actual targets and predicted targets, but before that we have to get the prediction from the neural network. Neural network prediction එක ගත්තේ නැහැ. So model.predict test data, right? And predicted targets. Right, and then we can measure the accuracy between the actual targets. Actual targets are in the test target, and here this should be target. I mean, fine, but yeah, so predicted target. So we can print the R2 metrics, and we can print the R2. Yeah. So R2 score is quite low, right? I mean, it's like 66. So that's similar to like accuracy of 66. You know, so R2 score is 66. That means like we can get the idea that the what you call, it's like similar to a classification problem which has an accuracy of 0.66. Make our accuracy of 0.66 තියෙන regression, sorry, classification problem මේක results වලටම සමානයි, right? But I will show you something now. This R2 score illustrate, or like it represent that this model is not trained well, but we can't conclude that. We can't conclude that, okay, so this is not a good model. We can conclude it from here, right? We have a low accuracy, low R2 score, sorry, not accuracy, low R2 score, but we can conclude this is not a good model from here. I will show you one thing. Let's plot these things and see, right? So let us plot these things and see. I mean the predicted and the actual targets, and see what has happened. PLD dot plot the predicted the actual targets and also the predicted targets. That will be, yeah, predicted targets. And PLD dot X label, probably we have to include the stock value, and PLD dot Y label, the what you call the date, and PLD dot legend, and finally PLD dot show. Right. Okay. Now what you see? Huh? Right. So that's why data visualization is important. Right? Data visualization is important. So what's the thing that you are going to, I mean, what you can conclude from here? Huh? Yes. I mean, the what I mean was like the values are not like, I mean, values are not uh, close to each other. But can you see predicted target is like, I mean, it has identified the pattern, right? පේනවද මේ predicted target එක ආර්යා විදිහටමයි වෙනස් වෙන්නේ. pattern එක අඳුරගෙන තියෙනවා. It has identified the pattern. What's the issue here? I mean, there is a shift, like a downward shift is there. Now, when you're analyzing time series data, this is important. Now, don't conclude, okay, R2 score, we are getting a low value. This is not a good model. No, you can't do that. You have to like visualize it and see what are the values you are getting. And the graphical visualization is the most important thing that you are going to see. If you are going to plot this, then you will see, okay, so it has identified patterns. It has predicted the pattern well. Predicted and actual targets are quite the same. I mean, if you compare the pattern, but there is only a downward shift in predicted targets. That's not the issue. Why? Right? So shall I mean, here, let me add predicted targets. Let me add manually, right? Let me add for the old values. Let me add a value like 0.05 here. So let me add a value like 0.05. Right? So now we are going to add value manually, right? So see, R2 score now become 93, right? A very good model, right? R2 score become 93. Now, but you can see almost the same, right? With little deviations, right? So what was the issue? Now the LSTMs are good in pattern recognition in sequence data, time series data. So that's what we discussed on last time. Now it has identified the pattern correctly, but the value is not predicted well. It's like, I mean, due to some reason, it's like a shift is there, right? But it's a continuous shift, I mean, constant shift for all the values. So what you can do, you can manually like rectify it. I added 0.05 manually. Why? I saw like there's a gap approximated. I mean, there's a gap between all the values. Like it was like 0.05 by looking at the graph, right? So I will show you that again, right? So if you analyze this, you can see right here. Let's see from here to here, like that kind of gap is there, right? So what I'm going to do, I'm going to add it. I mean, sometimes it's like adding a constant. Sometimes you have to add the like y equal mx value, right? දැන් මේක සමහර constant එකක් අපි add කරේ හැබැයි සමහර වෙලාවට ඔය gap එක, right? So sometimes the gap might be like larger when you are going to increase your date. I mean, increase the x value. So then you can, I mean, add this thing using y equal mx kind of equation, right? But for now, I mean, you can see 66 become, right, 93 when you are going to add this. See, right? Understood, right? Understood, right? Okay, now I mean, yeah, so that's it, right? And other than that, what we have discussed, yes. So then, so this is how we are going to do the time series prediction. And the other important thing is that, like, we have this. So please do this and like try to implement this. And other thing is here. This is getting good predictions. But other than that, what you have to do now to get the exact value, I mean, if you are going to print these values, the predicted target, right? The predicted target, you are going to get a value between 0 and 1, right? So we have normalized these things, right? To scale down, min-max scaler, using min-max scaler, we have scaled it down, right? So what we have to do, we have like, we have transformed it. So we have to inverse transform them, right? So what you can do, now this scalar here, we have used a scalar here. You can remember, right? I mean, probably in the earlier code, 1.2 data pre-processing. So we have used a scalar, right? Here we have used a scalar. So what you can do, you can save this scalar, right? You can save this scalar using pickle, import pickle. Sorry, not pickle. Joblib library. You can use the joblib library. Import joblib, right? And what you can do, like joblib.dump. I can save this scalar. This is scalar. You have to save the scalar. Scalar. You have to use the format called pickle format, and you can save the scalar. Not scale open value. You have to save the scalar, right? The scalar will be saved. So run it, and sorry, we have to interchange the file name and the object to be saved, right? Using joblib library, yes, I have saved this. So what's going to happen? This scalar will be saved as a physical file here, right? This one. So then what you can do here in the second code, you can load it here. Import joblib So what you can do is scalar is equals to joblib dot load. So if you don't have the joblib, you have to install it using pip install joblib. Right, keep that thing in mind. And we have load the file scalar dot pkl. Right. So I have loaded. Now what we can do? We can transformed predicted target, right, equals scalar. Now here what we did, like can you remember, we like transform it to a value between 0 and 1. You can remember, right? We transform the open value into a set of value in between 0 and 1. So here we are going to inverse transform. So scalar dot inverse transform. Transform into inverse transform. So you have to give the like this predicted target. Predicted target. And let me print the predict transformed, I mean inverse transformed. Right. So can you see now? They are transformed to their real value. Right. Real value. So this is in dollars. Right. So the inverse transform is done like this. Right. So I have like in the code that you are going to do the scaling, you have to convert it, right, to a scalar. Not here, this one. You have like convert it to a scale value between 0 and 1 to train the neural network. After getting predictions, after training and after getting predictions, you have like inverse transform it to get the real value. So you can save that scalar, right? You can save that scalar using joblib module. Like you can save it to a physical file. When you are going to get predictions, you can load that file, right? Then we can load that file, and we can load that file and do the necessary transformation, I mean retransformation, inverse transformation, and get the real value, right? So that's how we are going to do. And now you may wonder, okay, everything is okay. We got the results, we got the very R2 score, good R2 score, and we got like a good model training, right? So we have this training data, right? So everything is there like good, right? So getting predictions like this, and we shifted it, and now it's giving good values, right? So that's what we have to like see, and we have seen up to now. Now my point is, okay, so how to get the prediction, right? So how to get the prediction, right? How to get the prediction? I mean, how we can get? I mean, how we can use it in real life? Huh? How we can use it in our real life? Yes. කොහොමද අපි මේක ඇත්ත ලයිෆ් එකේ දැන් හරි Apple වල හෙට stock value එක කොහොමද read? Now what this model needs, right? This model needs 50 values. Those 50 values should be like past 50 values. So what we are going to do today, yesterday, likewise, we are going to go back in the past and we are going to collect last 50 days what? Last 50 days stock value, right? So we can collect the last 50 days stock value, right? So let's say now, I mean, from test data, right? Test data 0, let's say test data 0. I'm going to assume this. මේක තමයි test data 0 වල තියෙන right? So we have something like this, right? Okay. Let us see, like, I mean, uh, data, right? So let's say data, uh, open, no, we have the data, right? Okay. Okay, now, I mean, I want to show you how to get a real world prediction, right? So how you can do that. Uh, let's say test data, right? Test data. And what you are going to have, like, stock value of 50 days, right? I just show you these values, right? I mean, I use I will use random values, right? I will use a set of random values for now, right? This is not correct, right? But I won't like do this quickly. That's why I'm doing this. So random values, random dot random integer. Now these 50 values not should be like this, right? Right? Like you have like 50 days, real value should be there. I mean, now these are, I mean, let's just assume that these are the last 50 days values, right? This kind of array, right? This kind of array. Uh, random integer, right? අපි දැනට හිතමු හරි මේවා තමයි දවස් 10 values දවස් 50 values ටික කියලා. right? අපිට කොහෙන් හරි ඕක ගෙනලා දාගන්න පුළුවන්. It can be like a data set, it can be a API, a real, I mean, live updating API. We can get this value somewhere, we can get this value, right? From a API, from a mobile application, from a web application, from a web server, we can somehow get these values. Let's say මේ වගේ values 50ක් මේ තියෙන්නේ. අදත් include, right? 50 days including today, right? So now what we are going to do, we are going to predict the tomorrow's value, right? So what we have to do, right? What we have to do first, yes, we have to reshape it to like a column vector, right? So we have to reshape it to a column vector. -1 1, probably I think you can remember, we need to like have two-dimensional data. So test data, we are going to convert it to a value like this, right? Then you can probably print it and see, right? Good, right? So you have this kind of a data set, and then what you have to do, right? Then what you have to do, can someone tell me? Yes, now we are going to apply this to the neural network. Yes, quickly, quickly, we are running out of time. What we have to do next, we have last 50 days data, right? Now what we have to do, yes, yes, අපිට දැන් දවස් 50ක data තියෙනවා. හෙට එක තමයි අපි predict කරලා ගන්න යන්නේ. මොකක්ද අපි ඊළඟට කරන්න ඕන? Yes, anyone quickly? What we have to do next? What we have to do next? Yes, 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 yes. What you have to do then? Before applying these, I mean, අපිට දැන් image එකක් දැම්මම cat the dog ද කියලා වෙනදා කියනවා වගේ දැන් දවස් 50ක previous දවස් 50 data දැම්මම හෙට stock value එක මොකක්ද කියන neural network එකක් අපි ගාව තියෙනවා. We have a neural network, like similarly when we are going to upload the image, it's going to say cat and dog. Similarly, we have an image which like can take 50 days stock value and predict the tomorrow's stock value. Yes. So what we need to do then? No, fit the model into this data. No. Before that, an important point. We have to what? I want to get it from you. Like images, can you remember? When we are going to like apply a test image into a neural network, what we did? Like we need the color conversion, we did the other, like we need to do whatever things we did for the test training data. So what we did only what's the only thing that we did for like the training data? What's the only modification we done? Yes. අපි training data වලට මොකක් හරි modification එකක් කරලා දාන්න කලින් yes what? Hayo. I mean, you have to, I mean, note these things. Neural network එක දාන්න කලින් train data වලට කරපු දෙයක් මේකටත් කරන්න ඕන test data වලට. මොකක්ද? What's that? Yes? Categorical, no, we are using a regression problem, right? We are using a regression problem. So why we need to categorize them? මේ දවස් 50 stock values ටික මොකද අපි කරන්න ඕනේ neural network එකට දාන්න කලින්? I'm not going to say, you have to say it. Otherwise, I'm not going to. Yes, yes, yes. Finally, you have to normalize it, right? So how we are going to normalize it? We have the scalar here, right? So scalar, what we can do using the scalar, scaled test data we can get, scale test data, scalar dot fit, scalar transform test data. Then now we can add, right? So now you can get the prediction model dot predict scale test data. Probably we have to send it like two-dimensional array like this. Then the result can be taken here. Okay, three-dimensional input is required. I think we have reshaped එක කියන්නේ අපි දෙන්න ඕනේ මෙයාට 2 3-dimensional විදියට. ඒ කියන්නේ test data equals sorry, scale test data equals we have to convert it to like reshape (151). මොකද අර මේ predict එක මම කියවනේ බලාපොරොත්තු වෙන්නේ 3-dimensional විදියට. ඒකෙන් අපි මේ විදියට යවන්න ඕනේ. Now probably it should work. Yes. So you have the result now. So this is not the result, right? But transformed result you have to get transformed result. Scale dot inverse transform. So $93 transform it. So please go through the video again, right? Now I have covered lots of things today, right? And this transformer and I'm transforming scale down and like how to train, how to design the LSTM, like lots of things. So please go through the, I mean mostly like the last part of the lecture, right? And I have now explained how to get this kind of a prediction, right? I mean, now here what happens? Like we have the last 50 days, right? So we have the last 50 days, right? I mean the data of last 50 days, right? The data of last 50 days. And if we have this, we can predict the stock value tomorrow, right? So this is how we do it, right? So we have the tomorrow stock value, right? And this is a bit accurate now. I mean, quite accurate model you can see, right? So it's like the predicted and actual targets are quite similar. So good model to be used, right? So I will upload the tutor, I mean the assignment. So in this assignment, it explains how to use one-dimensional convolutional neural networks to for time series data, not LSTMs, right? One-dimensional convolutional neural networks to LSTM, sorry, stock value prediction. That means time series data, right? So what's going to happen in one-dimensional convolutional? What's going to happen, right? So can you remember what happens in images, right? So I mean, convolutional neural networks are doing feature extraction. You can remember, right? So what's going to do? Like we have a kernel, and the kernel is going through this image and extracting. So that's how the two-dimensional convolutional neural network works. But one-dimensional, so then they are designed for like time series kind of sequence of data. Like we have 50 days like this. So what we can do? We can create a one-dimensional convolutional neural network like this, right? So it will extract feature by sliding only in one direction. Now here, this is sliding in both directions, right? මේ පැත්තට ගිහිල්ලා පල්ලෙහාට ගිහිල්ලා ආපහු මේ පැත්තට ගිහිල්ලා ආපහු පල්ලෙහාට. Like it's like first, I mean, row wise, column wise, this feature extraction is done. But one-dimensional convolutional neural networks, only feature extraction done in like one direction, right? So please have a look on this assignment that we are going to get in this week, right? And try to implement this convolutional neural network for pattern recognition in time series data, right? Okay. So quickly, if you have any questions regarding whatever things we covered today and the assignment and anything, please ask them now. Anything to be clarified? Okay. So thank you very much then. Hope you are following the tutorials and the assignments and the videos, right? I hope. And please do your, I mean, week by week, please complete this thing and like concrete the idea of what we are going to cover on week by week, right? Otherwise, if you are going to miss 1 week and okay, like then you are going to miss the live lecture since you don't have the previous week's knowledge, then you are going to miss the live lectures and you have missed 2 weeks, right? Then like you are going to miss 3 weeks, then you are going to miss the course, right? So don't do that. I mean, hang on this like week. I mean, I'm not going to do that much things on a week, right? I mean, we are doing like only assignments and tutorials are given, so you have to follow those things. That's what you have to do, right? Understood. Okay, so with that, I will conclude the session. So please do whatever the things in this week, right? Week by week, please complete. And we are now, we have finished the supervised learning. We have covered feed forward, convolutional and recurrent neural network. So then we have to move to the unsupervised learning from next week onwards. So autoencoders will be started on next week Saturday, right? So we will meet on Saturday and have a good night. And please do your work and keep in touch. Right. So thank you very much and meet you on Saturday.